Okay, so thank you so much for having this lecture 5 for inviting me to have this lecture 5. So first of all, before we start, I just want to say that I'm quite happy because I saw that quite a number of people submitted the assignment, right? Assignment 1, and yeah, and most of you answered all the questions. In fact, all the students answered all the questions, which is quite nice to have because yeah, some courses in USM, sometimes students don't submit, then the lecturer will be like we cannot sleep every day, thinking that why the student did not submit, did we do anything wrong? But then I'm quite happy to see almost everyone submitted. Okay, so yeah, congratulations on that. So just to recap on last week's lecture, we want to start off with a recap so that we remember what we learned about in the previous lecture. So we already gone through the introduction, and then after that, we also look into the dose-response relationship. So I can see that most of the students answered the dose-response relationship questions in the assignment correctly. And then after that, we also look into toxicokinetics and toxicodynamics, whereby we talk about exposure phase and toxicokinetic phase with absorption, distribution, metabolism, and excretion, right? And in the last lecture, we look into this toxicodynamic, whereby we look into all these different kind of toxicity on our different organs. For example, we have hepatotoxicity, we have this neurotoxicity, we have dermatotoxicity. So all these toxic effects are induced by toxicant when they are absorbed into our body. So we want to go through the last part of our toxicodynamic lecture, which is on neurotoxicity. So this neurotoxicity basically is the toxic effect to your nervous system, or our central nervous system, or CNS. So which means that this is a toxicity that is induced to our brain or spinal cord, right? And if you look at our spinal cord, it has a lot of different kind of morphology in terms of the cell structure compared to the rest of the body. In this central nervous system, you have something like this, what we call as neurons, right? The shape of this neuron is quite unusual, and then if you look at it properly, you can see that the connection between different neurons, it has something like this, right? You look at the figure over here. This is basically, I would say that elementary schools syllabus, right? If you look at the secondary schools, right, they talk about this kind of structure and what is the benefit of this structure. So I will not go through this in detail in how it looks like. Just to explain to you that basically the neurons are very important to our body because it transmits signals, right? From one cell to another, there's this gap over here, whereby you can see there's chemical reactions, right? So there are a lot of different kind of molecules which is used to transmit chemical information from one neurons to another neurons. And if there's a disturbance, right, during chemical signal, okay, during chemical signaling, then we will have inhibition of the signal at a specific point, and we may not be able to control certain part of our body, right? So for example, if you have disturbance in the neurons in the maybe spinal cords, then maybe you will have no sensation to your legs. Okay, sometimes you have shaky hands, right? For instance, if you look at the disease, Parkinson's disease. Parkinson's disease is one of the diseases that affects your neurons, right? Central nervous system, whereby you can see a lot of this patient, right? Parkinson patient, they have their hands shaking continuously, uncontrollably. It's because of the disturbance to their central nervous system, right? So neurotoxicity can happen when you have disturbance. As I said, you have disturbance in the connection, okay, between one neuron to another neuron, right? So if this kind of disturbance happens, right, what we'll see is that there are many ways. Okay, for example, you can have disturbance in the sodium and potassium transport, because this potassium and sodium, they are important in generating electrical potential. You can also have passive reverse transport, initiates cascading depolarization. So when we have this neurons connection, we have polarization, depolarization for the signal to be transported from one to another end, right? So if there's a disturbance, then of course this signal cannot be transmitted. Okay, so sometimes when you have this kind of transmission of signal, your neurons will release certain chemicals, like for example, acetylcholinase, right? Acetylcholine, sorry. Yeah, just to show you. Yeah, so it will release this kind of chemicals during the chemical signaling. And when you have these chemicals in your synapse, right, you have to remove it. Usually we have an enzyme that can be used to remove this chemical, which is what we call as the acetylcholinesterase, right? We have this enzyme which can carry out hydrolysis to remove this molecule. So if you have a certain inhibition to this acetylcholinesterase, then you have poor signaling, which can inhibit certain interaction between your different neurons, right? So just to show you how it works. So this is the enzyme, acetylcholinesterase. And then this enzyme has two different binding sites, right? And you have acetylcholine binding to the enzyme. And then after that, you have hydrolysis reaction happening. So if you have certain chemicals that can inhibit this activity, okay, the activity of the enzyme, what you'll see is that, for example, you have this parathion, which is an insecticide designed to inhibit this acetylcholinesterase, right? So it can inhibit a certain binding sites of your enzyme, and then after that, it can lead to this irreversible reaction, whereby you have a strong attachment here, right, to this one of the binding sites, and this enzyme becomes not usable anymore. So because of this effect, you will have accumulation of your acetylcholine, and then after that, you will not be able to hydrolyze this, and it will cause toxic effect to your neurons, right? So this is one of the reason why this kind of insecticide is very successful, because it inhibits certain functional groups in your enzyme, okay, causing a paralysis effect. So one case study related to neurotoxin is this case study in New York City, 1994, whereby in this case study, you can see that there's several people drinking tea, right? So they drink tea purchased from Paraguay. It's labeled as Paraguay tea, right? So this is purchased from South America, right? So what they did not realize is that this tea contains certain chemicals, right? That can inhibit our CNS, central nervous system. And they observe several symptoms. For example, they have agitation and flushed skin. They have acute symptoms, which means that they ingested a large dose of this chemical, right? Then they go to the hospital, and then after that, they found out that these persons, they are actually poisoned by acetylcholine neurotoxin, right? So from here, of course, they are issued 2 doses of this intravenous physo. I can't pronounce this name. It's sometimes it's very difficult to pronounce. Yeah, this is a dose that can actually compete and then reverse the effects of the this cholinesterase inhibitor, right? Another one that just to share with you is that there's another case study, which you can search if you are interested to see what is actually happening to this this horse over here. This is actually a equine. Okay, equine is like a horse creature, right? This equine, it can be can be poisoned by this kind of flower, right? This is a yellow star crystal. This flower, if it's taken by this animal, you will have certain irreversible toxic effect to their brain. You can see over here, there's black in color. This is actually damage to their structure, their brain structure. And because of this, it affects the central nervous system, and they will die, right? Due to the inability for them to transmit signals of their neurons from one end to the other end. So this is one of the cases whereby neurotoxin is occurring in the nature and affecting the animals in a certain area. Okay, so in week five, we are going to look into mode of toxic action. We want to talk a bit more on the chemistry part, right? Want to know a bit on the classification of this different kind of environmental chemical, and then after that we want to look into what are the mode of toxic action of these environmental chemicals. And finally, we would like to explore a bit on the transport of chemicals from one site to another site, right? So before that, just to talk a bit on the assignment, presentation assignment 2, right? So if you go to the website, whereby the website where you download your assignment 1, you'll see that there's a link for assignment 2. So this assignment 2 is on the presentation assignment, right? So you have to go to that website, download this instruction, and then first you need to identify your pollutant, right? For this instruction, you need to identify pollutant. Okay, you can be anything. I prefer it to be the pollutant of emerging concern, which means that it is something that we are struggling with nowadays. But if you cannot find one, okay, of course you can select one that has been well known. For example, lead, bisphenol A, aluminium, ions, and then you have DDT, and all these kind of pollutants, or dioxin, right? So you need to prepare a presentation which can be used to raise awareness. Okay, let's say you go to a village, right? You want to let them know that this is a pollutant. So instead of you presenting and saying that it's a pollutant, you show them a video, right? That will be the best case. You show them a video so that they can be aware. Okay, you show them all those photos and pictures. What are the impact of these pollutants and how this pollutant can affect the population. So you have to prepare this video or the presentation, right? And discuss the possible sources of the pollution and evaluate the toxicosis of the pollutant. So one example is mercury. So mercury is one of the pollutant that can cause central nervous system damage, right? So you can discuss, right? What are the sources of this mercury? Okay? Is it anthropogenic? Is it from different natural occurring sources, or is it from man-made chemicals? And then after that, you look into the toxicosis. What is the effect of this mercury to human? Okay, and if you don't want to look into the effects to human, you can look into the effects to plants, effect to animals, and so on, right? So download it and look at the instruction. And if you have any doubts, just let me know. I will try to clear your doubts. Okay, so outline for today would be very simple. One is the classification, okay, more on the chemistry part. Second would be to describe the mode of toxic action, and the third one would be looking into the transport of the toxicant. Okay, so if you look at the environment, if you walk around the streets, it's full of environmental chemicals. It is everywhere. Either it is from human or anthropogenic, or it can be from natural sources, right? So all these different chemicals, we actually can classify them into different categories. Okay? And in fact, there are many ways to classify the chemicals. For example, you can classify them based on chemical type, which means that you can say that it is heavy metals. Okay? For example, if you have contamination from lead, you have contamination from mercury, arsenic. You can classify all these contamination as heavy metal contamination. So you have pesticide contamination. Those chemicals, organic chemicals that are used to remove pests, right? You can classify everything into under pesticide category. And then if you look at another classification, solvents, you can actually classify things like methanol, ethanol, all this as your solvent, okay, as one of the class of your chemical, right? So some people like to classify it based on physical properties. Right? For example, you can classify based on these DNAPLs, like dense non-aqueous phase liquid. You can classify based on VOC, okay, volatile organic carbon, or you can classify based on RCRA, which stands for Resource Conservation and Recovery Act, okay, characteristic waste. Okay. All these, they have certain physical properties. You can also look into classification based on PBT, which is persistent bioaccumulative and toxic chemicals, right? So another one is regulatory or other lists, like, for example, priority pollutants, RCRA listed waste, or CICRA hazardous substances. And then the other one will be source, pathway, and endpoint, whereby we classify based on the source. For example, I'm sure you heard of people saying that this waste is agricultural waste. So when you hear the word agricultural waste, you know directly that this waste is probably pesticides or maybe nutrients like phosphorus or nitrogen. So some people talk about the classification based on pathway, okay, like pathway in terms of whether it can be transported through wind. Okay, let's say we say that it is something that can be transported through wind, then we know that these chemicals may be volatile chemicals, right? Or sometimes we use endpoint for classification. Okay, endpoint means that the effects, okay, the final effects that can be induced by the pollutant. For instance, we talk about central nervous system damage. So we directly know that the chemicals belonging to this central nervous system damage will be like, for example, mercury, or maybe arsenic, right? So the reason why we have all this kind of classification is because we need to know how to manage it properly, right? So management of heavy metal pollutant is different from management of pesticides pollutant, right? So if we know the class of the chemical, we can actually manage it to a better extent, right? So another reason why we have to classify the chemicals is because we need to know what kind of treatment method, okay, that can be used to treat the exposure, right? If a person is exposed to heavy metals, right, the treatment method is different, okay, compared to when the person is exposed to things like pesticides or maybe some other toxic compounds, right? So the management type and the treatment type will be different, okay, depending on the classification of the chemicals that you have been exposed to. So if we talk about classification based on priority pollutant, generally this is one of the very important pollutants, right, that are of emerging concerns. Right, so this priority pollutant basically are chemicals that are listed under this section 307A1, right? And this is one of the very famous section. You can see this almost everywhere. Everyone is talking about these priority pollutants, right? This is in the Clean Water Act, okay? You can see this is 1977, it's quite old, but the list of the pollutant is actually dynamic, which means that it is constantly being added. Right. So every time when we have data saying that this chemical is dangerous, this chemical has caused problem to the human health, then it will be added to the list. Right. So this list is basically to provide guidelines when we want to regulate certain industrial discharge. Right. Guidelines means that we give recommendation. Okay. and impose certain regulation to the industry, saying that they cannot release this chemical above a certain threshold, right? So if you look at, let's say, phenol, right? So this guideline say that say you cannot release phenol above, let's say, 10 ppm, right? So the other way of presenting this guideline will be to impose a treatment method that has to be followed by the industry, right? For instance, this guideline also said that if you have this kind of pollutant, you have to go through a specific treatment method before you can discharge it. Okay, so two things. One is imposing the limit of discharge. The second thing is to impose a treatment method before it can be discharged out of the industry, right? So there are many chemicals in this priority pollutant list. For example, antimonies, you have thallium, asbestos, acrylonitrile, carbon tetrachloride, and so on, right? So it is dynamic, as I said. Every time we have new data, it will be those chemicals will be added inside, right? So you have thallium, you have this one is asbestos, and then we have nitrobenzene. This chemical is very commonly used in my lab, nitrobenzene, right? So it's quite hazardous. Okay, so if you are using these chemicals, right, you have to make sure that it is not going to be in your skin, right, on your skin, because this chemical can be absorbed easily by your skin, right? And then after that, it goes to your liver, and then it goes to cause certain toxic effect to your body, and it is carcinogenic, right? And then the other class is this persistent, bioaccumulative, and toxic. Persistence means that it's very difficult to degrade this kind of pollutant. It will be in the environment for many, many years, in many generations. Bioaccumulative means that it can be in the organism for a long time, and it can move up the chain. For instance, let's say you have a very small fish, right? Each of these contain a small amount of pollutant, right? So if a larger fish eats three of these small fish, then this larger fish will have three, right? Three of this pollutant. So if a even bigger fish, right, eat three of this larger fish, then of course it will have a lot more, right? You have 9 portion of this pollutant, right? So as you move up the food chain, the chemicals will be accumulated in the body at a higher dosage, which will cause something that what we call as a biomagnification, right? You can cause the higher end of the food chain to have more of this pollutant in their body, and in the end they will have effects to their reproductive, the developmental, mutagenic, carcinogenic, and neurotoxic effects, right? So it can be a very serious problem, because human generally is at the end of the food chain. So if the lower end of the food chain is contaminated, so eventually you'll move up to the human, and then after that it will cause issues to our health. So and an example would be if you look at the case study that I presented, I think last week, okay? The contamination of chemicals in the food of animals, right? In cows, right? So if you can look back at the lecture, during that time in the US, they have these issues of mixing up the pollutants and the food. So when they mix up, then of course they feed the cows, right, with the pollutant, and then eventually they have to kill all the cows, right, because of these issues. So some chemicals belonging to this class of persistent, bioaccumulative, and toxic includes this aldrin, alkyl lead, you have DDT, dioxin, hexachlorobenzene, all these chemicals. One example would be this octachlorostyrene, right? This chemical contains a lot of chlorine, right? You can look at the structure. You have a lot of chlorine, and usually compounds that has a lot of chlorine is generally hydrophobic, right? And very, very difficult to degrade in the environment, right? Very toxic, right? So if you release it in the environment accidentally, then it causes a lot of harm, right, to fish, to human, right? Because this is hydrophobic, it can accumulate in our tissue. Another one example is this, what we call as arsenic poisoning. This arsenic is one of the heavy metals that is of concern in many countries, particularly in the countries whereby water is very difficult to get, right? So arsenic poisoning happens in water, groundwater, right? Mostly in groundwater, but sometimes it can be in a lake and a river. Right, so one case in Malaysia, we studied this arsenic level, right, in this area, Air Ganda, and this is in 2019. Okay, it's like quite recent also, and we actually found that the arsenic level is double the permissible limit. This is important because some of the wastewater treatment plant and water treatment plant, they are not designed to remove arsenic, right? So generally, the treatment method used for treating water in Malaysia is very simple, right? Because our water is relatively clean. Okay, so sometimes we don't account for this kind of chemicals like arsenic. So it's very problematic because if you look at the poisoning effect, right? This arsenic can actually accumulate in your body. Okay, it can be in your hair, it can be in your sweat, it can be in your certain tissues like bone, it can be in your bone, right? So if they are present in excessive amount, it can cause many kind of damage, like skin damage, cancerous, nerve damage, circulatory problem. So the toxicosis of this arsenic is already well known, right? We know what kind of things, what kind of effects this arsenic can cause to our health, right? So this is one of the important thing of classification, right? We classify it as arsenic, and then we know what kind of effects it can cause, and what are the possible solutions to remove arsenics from our body. Yeah, as I said, arsenic is something that is happening not only in a certain area, but it's actually a global issue, and mostly in the developing country, okay, whereby water is like not properly treated and clean water is rare, right? One example would be this in Bangladesh, right, whereby they have contaminated water, right? Most of their water, they are clean, but then in certain parts, of course, they have arsenic issues, right? So if the arsenic issue goes into the agricultural area, for instance, if you look at this, right? This is a paddy, right? Paddy plant, right? Whereby it's contaminated, right? This area is contaminated with a lot of arsenic. So the plant can actually uptake the arsenic. You can see here, right? Arsenic through their roots. It goes to their stem, and then after that, eventually to their their husk, rice husk, right? So it can accumulate in their rice, right? So because of this, of course, it is quite dangerous because you are actually eating all those arsenic. So what they found was that, okay, their water have arsenic, their rice have arsenic, and then when they cook it, the arsenic concentration increased significantly, right? So they start to explore why this happens, why when they cook it, the arsenic concentration increased. They found two reasons. One is because of the effects whereby you have chelating effect, right? You can see over here, you can read through this. And then the other one is because of the arsenic being more concentrated because of the evaporation of the water during cooking. So this shows that for heavy metal contamination, we actually have to be more careful because heavy metal can undergo many kinds of transformation in the water, like chelation, right? It can cause the arsenic itself to become undetectable, right? It can also cause arsenic to be less likely to be treated by our water treatment plant because different kind of structure, different kind of complex have different treatment efficiency, right? So arsenic that is bounded with a certain ligand may not be easily treated compared to arsenic alone, right? So we also look at this two examples. One is this propanil. This is a herbicide widely used in Sri Lanka, right? So this herbicide has caused a lot of issues. For example, you have methamoglobin anemia. Okay, this is a blood-related issue. Your erythrocytes got inhibited because the hemoglobin in the erythrocytes, they are affected by this propanil. Okay, so this caused the red blood cell to be unable to carry out respiration properly, which means that the transport of oxygen and carbon dioxide is very difficult to happen, right? So when you have this kind of effects, right, your red blood cell cannot function properly. So it causes something called a tissue hypoxia, okay? Which means that it makes your body have less oxygen, right? And this propanil can also cause like depression in the CNS and respiratory system. Okay, so we need to know, okay, we need to classify this under herbicides or pesticides pollution. Okay, at least we can know how to manage this kind of symptoms, right? And the other one is glyphosate. Okay, this is one of the problems also in Sri Lanka, right? So many years back, Sri Lanka used these chemicals, glyphosate, as one of their herbicides, right? And then after that, the government issued an order to stop it, right? Because this glyphosate is one of the chemicals that has caused issues to the health, the public health, right? This glyphosate has low to very low toxicity. If you look at the dose-response relationship, you will find out that this kind of chemical is actually not so toxic. But then, as a chemist, we usually are not satisfied, right? We want to look into something that is deeper, right? More in depth. We look at the structure itself, right? Look at this, it has oxygen, right? It has nitrogen. So every time as a chemist, we look at this kind of structure, we know okay, this can actually become a ligand. It can bind with the heavy metals, right? For instance, you have lead, right? You can actually bind with this to form a complex, right? So this is exactly the problem of the glyphosate. Okay, glyphosate itself is very easily treated. It can undergo filtration. Okay, you use filtration technology, you can remove it directly. But if you have heavy metals in that particular area, glyphosate can actually bind with the heavy metals, and then after that, you use filtration, is not so effective anymore, right? You will see that this complex actually escape the filtration system. It goes to the drinking water, right? And then when someone drink the water, then you will have certain effects, toxic effects. And the other one thing that is problematic, right, for this kind of chemical is that usually ligands, right, can actually increase the solubility of heavy metals, which means that if you have lead, right, if you have this lead in a solid form, right, let's say this is a solid form, right, so you have the presence of glyphosate, okay, surrounding the lead. So this glyphosate can actually react with the lead to form a complex, right? So you have something like this, right? This kind of complex, right? So this complex is generally a complex containing lead that is soluble in water. So you can see initially you have lead that is not soluble, okay, the solid state. And then because of the presence of this glyphosate, you can actually increase the concentration of lead in the water, which can actually increase the toxicity of the solution itself, right, of the water itself, right. So the next environmental hazard or chemicals will be belonging to this ionizing radiation. This ionizing radiation can actually cause a lot of problem in terms of its ability to cause ionization of a certain certain chemicals in your body. Okay? It can cause chemical reaction. It can cause alterations of chemicals in your tissue. Okay? In other words, it can cause abnormality. Okay? For example, your DNA, right? Your DNA consists of deoxyribonucleic acid. And this DNA is a chemical, right? So if you have ionization in the chemicals, then you have a problem when translating that DNA. So you know that your DNA strands, right, they are immobile in your cell. And then you have RNA going into this DNA and then starts to translate information to build proteins, right? So if you have this ionizing radiation damaging your so-called DNA, right? When your RNA starts to go into the DNA and starts to translate the information, you will see that the protein that is built from the RNA will be something that is abnormal. So this is, let's say this, for example, this shape is normal. You'll see that the protein build is maybe abnormal, right? So this is an issue if it is not solved by our body. So if our body detect that certain cells, they are damaged, right, by ionizing radiation, of course we can have the trigger of certain mechanism like apoptosis, right, to destroy that particular cell, right, the damaged cell. But if the damaged cell is excessive, our body cannot destroy it. So it will lead into the translation of irregular molecules, which eventually can cause cancer. So this is why we heard a lot of cases whereby exposure to ionizing radiation has caused cancer, right? Most of the reactivity is in organism. In the organism is in water. Our cell consists of a lot of water, right? And because of this, it is a suitable platform for certain reaction to happen, right? And the creation of radicals, right? So when we are exposed to ionizing radiation, sometimes you can have the liberation of these kind of radicals like superoxide radicals, hydroxyl radicals, hydroperoxyl radicals, hydrogen peroxides, which can cause oxidative stress, right? So oxidative stress relates to the stress caused by our certain radicals to our body. And this kind of stress can actually lead into things like peroxidation, and it can cause excessive oxidation of our body and the activation of the enzyme. Okay? Yeah, so this is the oxidative stress that I'm talking about. It can cause lipid peroxidation, DNA strand breaks, enzyme inactivation, and all these effects. Right. Most of the time, it's because of these radicals, all these radicals being generated. One particular species that is quite reactive will be this CH3. Okay? This one can bind and alkylate our DNA. It has been proven to do that. And if this thing is to happen, which means it alkylate DNA, it produce, let's say this is a DNA, it produces CH3, right? It adds up this kind of alkane group into your DNA molecules. Okay, so eventually it will lead to an issue with the translation, and you will get cancer because of this kind of alkylation reaction. So we can see that there are quite a number of these radiation sickness that has been well documented. If you are exposed to radiation, okay, you have to seek help. Okay, at least you need to know what is the dose that you have been exposed to. So in terms of radiation exposure, usually we have a certain indicator, right? They need to wear certain things, right? I don't know whether you have seen that or not. There's a sensor in whereby they wear in your body, and if that sensor turns into very dark color, black color, right? Then we know that that radiation level is very high. We have already been exposed to it, and we have to get out from that area, right? So the effects, right, can cause radiation sickness, which can be maybe acute, Okay? It can be delayed, or sometimes it can be chronic, which means acute means that you are exposed to large amount of dose of radiation, and this radiation causes ionization of large part of your body, right? So instantly, within a few days, right? And then you have delayed effect, whereby the radiation induce certain change in your DNA, and then it takes several months, maybe several years for the cancer or maybe effects to come out. Then the other one is chronic exposure to a small amount over time, right? And typically we are actually exposed to this chronic, we are actually exposed to this chronic effect of certain radiation, particularly the solar radiation, right? So if you look at the UV ray, right, all of us are exposed to this UV ray every day. Okay? And the reason why this UV ray don't cause cancer, right, is because the dose that we are exposed to is not high. So if you stay in the sun for every single day, every single hour, then eventually you will get skin problem, right? Skin cancer, and right, because of the exposure to this solar radiation. Okay, so sometimes symptom can be not as serious, okay, very mild. Sometimes it can be very severe. Okay, it depends on the exposure level, right? It also depends on the energy, right? If you look at the radiation, right? If you're exposed to lower energy radiation, then you don't have to worry about it, right? For example, infrared radiation, this is heat, right? If you have microwave radiation, less powerful, okay? They are all considered as the non-ionizing radiation, which means that their energy is not capable of ionizing your cell, right? Because it can cause certain other effects, right? But that one is different issues that they are not of particular concern compared to the ionizing radiation. So if you look at ionizing radiation, they are of higher energy, right? You have gamma rays, we have X-rays, we have UV rays. UV rays is here, right? It's in between visible light and X-ray. So exposure to UV can actually cause a lot of harm too, although not as severe as the gamma rays. Okay, so if you talk about radiation, we are actually looking at several things, right? One is alpha particles. So these alpha particles have very low penetrating power. So it is actually consists of this radioactive release of particles. This is what you call as alpha particles. Okay? This is the helium, right? If you have an isotope, right, that can be radioactive, it can release these alpha particles, right, as one of the products during its nuclear fission, right? So when this happens, then of course these alpha particles will go everywhere, right? It will attack everything, right, surrounding its area, and of course it can cause ionization, okay, of your skins, of your tissues, of your body, right? So of course, alpha particle is less of a concern because although it can cause ionization, it is not as energetic, and our skin layer can actually protect ourselves, right, from being ionized, right? So it is only hazardous when it is inside our body, right? So which means that if you ingest something that is radioactive, then you have this alpha particle coming out from the things that you ingest. It can ionize our cell inside the body, okay? Because our body internal organ, they are not protected by the skin, right? Then we have the beta particles. These beta particles, they are basically electrons and positrons, right? The positively charged, we call it as positron. Negatively charged, we call it as electron. So this is one of the more energetic radioactive particles, right? This is what we call as a beta particle, more radioactive in terms of its power, right? Its energy, which can cause harms like skin burns, and it is also harmful when it enters our body. So this beta particle is although more energetic, but it can be easily stopped by metal or plastics. Right? It is not as energetic as the most dangerous one, which is the gamma ray. Okay? So this gamma ray is more powerful, short wavelength, and usually emitted by the nucleus. Right? So this is very penetrating, which means that it has very, very high power. It can go into the body. It can cause excessive ionization, right? So you have to be aware that when you have radioactive isotopes, right? When we ingest this kind of isotope into our body, right? And we must be very sure that that particular radioactive will not liberate gamma rays, right? If we ingest something, because if you look at the treatment, right? Treatment of a certain disease, for example, thyroid disease, right? They inject iodine, radioactive iodine into the body, so that this radioactive iodine can actually destroy the thyroid, right? So the reason why I bring this up is because most of these isotope, right, when we eat it in as a medicine, right, it will not only release alpha particles or beta particles or gamma rays. Okay? Generally, isotopes release everything, right? A particular isotopes can release gamma ray and beta particles concurrently, right? Most of the time, this is the case. So that's why when we want to use these radioactive elements as our drugs, right? Something that is beneficial, we have to be very sure, right? These particular drugs will not release excessive gamma radiation. It will not release excessive beta radiation that can cause our body to have cancer. So it doesn't make sense to have a drug that is used to treat one part of our body, but then it causes harmful effects to other parts of our body, right? So this is just to show you the penetrating power. Alpha particles, only a piece of paper can stop it. Then beta, you need thin aluminium. Gamma, you need up to thick lead. And then after that, you have these neutron rays, which can penetrate up to the concrete. Okay. So the next one will be the half-life. Okay, half-life is generally the time taken for a particular radioactive element to become half of its original power, okay, in terms of the intensity of the release of the isotope. For instance, if you look at this, right, this one is zero half-life, right? So the time taken for this brown particle to become greenish, right, to half of this brown cup become the greenish one, will be what we call as the half-life. So for example, if you start off with 10, after 10 minutes, it becomes 5. Then we can say that the half-life is 5 minutes. If it takes 10 minutes, then the half-life is 10 minutes. If it takes 2 years, then the half-life is 2 years, right? So generally, radioactive substances have very long half-life, right? So this is quite unfortunate because you know that sometimes we use these radioactive elements as a nuclear bomb, right? So if we drop a nuclear bomb in a city, right? So that particular city will be exposed to all these radioactive elements. And because some radioactive elements have very long half-life, up to thousands of years or millions of years, then that particular city will not be habitable for at least millions of years. So that's why nuclear bomb usage is very, very prohibited. And you don't see this kind of bomb being used widely. You look at the recent war, right? Russia versus Ukraine, right? This is something that I think very unfortunate that it happens, right? But then we don't see Russia sending nuclear bomb to Ukraine. Okay, one of the reasons is because of the issues that Russia will face if they send a nuclear bomb, right? So if they start off this, right, they will make Ukraine not habitable for many, many years. So the world will be very upset, right? And of course, land itself is very precious, right? So if we do this, then of course, we will limit ourselves, right? in terms of the availability of the land for us to use. Okay, so for these units for radioactivity, we usually use this 1 curie, which is equals to 3.7 times 10 power 10 disintegration. Right, you use this unit. Okay, this is to remember this girl. Okay, this woman over here. This is Marie Curie. She won a Nobel Prize 2 times. Okay, one is in physics, one is in chemistry. For her work in this radioactivity. After that, of course, it's this unit is replaced by this BQ, becquerel. Okay, and there's this 1 CI. This is Curie. Is equals to 37 gigabecquerel. Right. This is generally the conversion. Right. So as I said, the radioactive decay is not only one emitting one particle. Okay, so this kind of radioactive decay usually starts from paraisotope, and then it releases gamma, alpha, beta particles. Right. So after that, you will have this formation of daughter isotope with all those particles being released. And it's very radioactive. Right. So because of this, we have to protect ourselves. So we have this US EPA under authority of the Atomic Energy Act, whereby we start to impose limits on radiation exposure. Right. So this is one of the rules that limits human from being exposed to excessive radiation. Right. So we have to do this because we must prevent people from being exposed to radiation, right? So that they will not suffer from health effects. Right? And sometimes those people who are exposed to radiation can be radioactive themselves, right? So they have been exposed to, let's say, uranium, right? And let's say they have uranium in their body. So when they walk around, the surrounding people will also exposed to this kind of radioactive materials. So you have to take precaution, right? Okay, so let's look at the main factors when we want to evaluate the pollutant. So this one we talk about the classification, right? We can have heavy metals, we can have pesticides, we can have every different kind of elements, right? So here we want to look into what are the main things, right? When we want to evaluate the pollutants. Usually when we have a pollutant, we will look into the toxicity, whether that particular pollutant can induce long-term toxicity or short-term toxicity, right? So a pollutant in our body can have a very short half-life, right? Short half-life as in it don't really stay in our body for a long time. Sometimes it can have long half-life, right? So if it has long half-life, generally it can cause something called a long-term toxicity, right? Because it stays in our body for a longer time, it can induce more toxicity, right? Sometimes we also look into whether it's persistent or non-biodegradable, right? When we evaluate a certain pollutant, we want to look into whether it is inert, okay? Inert as in it doesn't cause any harm to human, or it is toxic, right? So usually persistent chemical found in the environment are things like chlorinated compounds. For instance, if you have this phenol, right? If you have this chlorine attached to it, okay, this is one of the examples that a persistent molecule, right? So if you have phenol, it is less persistent compared to when you have a lot of chlorine attached to the phenolic compound. Right, so we evaluate this because we want to know, okay, whether these chemicals, is it going to be there in the environment for a long time, maybe like 10, 20 years, or is it going to be degraded easily in the sense that when we add it into the water, it has hydrolysis reaction, okay, it has a photolysis reaction, and then it becomes something else, something that is less toxic. Right, so we will look into whether it is able to survive in the environment or not. Right, so we also look into whether it's degradable in terms of mostly organic substances, right? Organic substances, they are degradable because they can be used as a food source for bacteria. Okay? And then in terms of degradability, we also look into whether it is radioactive. Right? And then we also look into bioaccumulation, right? See whether this particular pollutant, is it going to be in the body of a fish, and then it can be accumulated over the food chain. Okay? Then distribution behavior, this one have to do with the transport of a chemical. Okay? The transport is very important because it can determine whether that pollutant is a local problem or a global problem, right? So if it's a local problem, then of course we can solve it much easier than if it's a global problem, right? So we also look at the transformation. This one we will cover in the transport lecture, right? And all these different kind of factors that we look into actually determines the degree of difficulty to control that pollutant, right? So if it is persistent, because it's more difficult to control compared to if it is degradable. If it can accumulate in a certain species, of course, it will present a challenge, right, to remove it from the food chain, right? So if it can undergo certain transformation, for example, photolysis, right, or hydrolysis, then it is easier to control because we don't have to worry about its persistence in the environment, right? So there are several questions that we must ask when we want to look into the impact of a chemical pollutant in the environment. One example would be, how long will the chemical persist in the environment? Okay. How long will it stay? Right? Will it be very stable and be in the environment for 100 years? Right? This is one of the questions that we must know. And usually we carry out certain tests to look into the stability of the chemicals, right, in certain environment. Right? So we look into whether it is stable under certain radiation, like under solar irradiation. We look into whether it is able to be hydrolyzed easily, right, and so on. Right? So we also look into how a chemical moves from one compartment to another. For instance, it can undergo disposition, volatilization, runoff, uptake, and so on. Right? This is related to the transport of the chemical. And we also talk about this food chain contamination, okay, when to evaluate its impact. So if it's not in the food chain, of course, it's safer, right? But if it's in the food chain, we want to know what is the extent of accumulation, what is the extent of depuration of that organism, and we want to understand bioconcentration and biomagnification, right? And then finally, we also want to know what is the physical and chemical characteristics, okay, of the chemicals in the environment. There are many kind of parameters that we can use to determine the characteristics. And for instance, let's look at these characteristics. Okay, so if I have a pollutant in the environment, right, and these characteristics has to be known, okay, because they are very important in determining whether a chemical, is it toxic or is it going to be something that is not of concern. But one parameter will be this water solubility. So this water solubility is measured in ppm and milligram per liter. This is the common unit, right? And if you have a pollutant with high water solubility, it means that this kind of pollutant is very likely to be mobile, it can be biodegraded, and it can be metabolized. Okay? Because it has high solubility, it can move easily in our body. Okay? It can be excreted out in the urine. Okay? So if you look at the previous lecture, we talked about phase 1, phase 2 transformation, right, in our body. So our body tends to want to make a particular chemicals, okay, from less hydrophilic to hydrophilic, right? So the reason is because we want to increase the water solubility, and high water solubility will give us advantage in terms of making the pollutant mobile, okay, biodegradable, and also we can metabolize it. Of course, high solubility comes with the advantage of unlikely to be accumulated. It is unlikely to be bioaccumulated also, okay, because we can release it easily. It is also less likely to be volatilized, and it is not so persistent. Okay, usually if it's very soluble in water, the vapor pressure will be very low, right? Compared to those that are hydrophobic. Those hydrophobic one, you can see that its vapor pressure is relatively higher. Okay, this is just in general, right? Let's say, for example, you have benzene, right? Benzene is very, very volatile. Okay, if you compare it with phenol, okay, phenol is more soluble, right, in water because of the OH functional groups. So it is less volatile compared to the benzene, right? If you have low solubility, right, on the other hand, you will have certain disadvantages. For example, this kind of pollutant is easier to be bioaccumulated, okay? And it tends to be persistent. But of course, the good thing is that in terms of the mobility of this kind of pollutant, it is less likely to be able to transport from one end to the other, right? Because it has very poor solubility, it tends to be adsorbed. And then it's also unlikely to be mobile, of course. Okay, so the next one will be octanol water partition coefficient. This one is generally means that the ratio between the chemicals in the solvent, is it octanol, and the water, right? So if you look at the solvent, right, you have two phases. One is the octanol, the other one is water, right? So this is just a ratio between your concentration between in the octanol phase and the water phase. Let's say you have 100 here and you have 1 here, compared to when you 1 here and 100 below, right? So if you measure the KOW, okay, the coefficient, you'll see that the first one will be 100, the other one will be 0.1. Okay, so this 100 means that most of the chemicals prefer to be in the octanol phase, which means that it is hydrophobic, right? And if you have high coefficient, that would mean that it is less likely to be soluble. Okay? It can bioaccumulate, it can bioconcentrate, and it can be adsorbed. So this has something to do with the solubility also. Okay, they are all related together. So if you, on the other hand, get 0.1 value, which means that most of the pollutant is in the water layer. So that will mean that you have low KOW value. That means that it is mobile, soluble, and biodegradable, right? And then hydrolysis half-life and photolysis half-life looks into how long it can persist in the environment. Then we have other parameters like density of liquid, density of vapor pressure, and all this stuff. Okay, you can go through this. They are quite straightforward. Okay, we have soil sorption, okay, which means to measure the ability of the pollutant to be absorbed by the soil. Then we have this TLC, thin layer chromatography reference, right? This all have to do with whether it is hydrophobic or hydrophilic and how it is mobile in the soil matrix. Okay, so let's talk about the toxic action of the pollutant. Okay, so this section is what we want to look into, how a toxic action can happen. Okay, how a pollutant can actually induce certain effects to a human body, and what kind of mechanism it follows. So if we look at the plant, okay, we start off with the plant first, right? We look at the plant. There are two ways whereby pollutants can enter into the plant. One is through the foliage, which means that through the leaves, right? These are the leaves, right? Whereby in the leaf itself, right, you will see that it has something called a stoma. In this one, right? So in this stoma, right, sometimes if you have excess water, it can open. Okay, and of course, sometimes you have this lack of water, or sometimes there's a signals sent by the plant to this stoma, it can close, right? So this open and close can actually regulate many things, right? It can regulate the ability of the plant to uptake certain gases. It can regulate nutrient uptake, respiration of the plants, and even regulate transpiration. Okay? But then, of course, because there's this open and close, okay, there's opening, right? So sometimes pollutant can enter into the plant through this stoma opening, right? So through this kind of passage, right, the leaf can actually be suffering from the toxic effect, okay, of the toxicant, right? So the other one will be the roots. Roots itself is one of the major areas of the plant whereby it can absorb water, right? It can have certain withdrawing of nutrient. Okay, these roots has certain structures that can uptake water, and in such a way that it can also sometimes take up heavy metals and pollutants into their system, right? So these two foliage, okay, or what I call as the leaf, and also roots, they are very important exposure points of the plants, right? So sometimes gases like sulfur dioxide, nitrogen dioxide, and hydrofluoric acids, these are just example, can enter into the stoma, and then it can cause harms to the plants. Okay, it can either cause acute effects or chronic effects to the plant. So the extent of uptake generally depends on many factors, particularly the chemical and physical factors of the pollutant. Just to show you, okay, how atmospheric pollutants can actually affect, okay, the plants. Let's say you have atmospheric pollutants, okay, and these atmospheric pollutants can come in the form of many types of chemicals. For example, SO2, NO2, or even hydrogen fluoride. Okay, so this pollutant can directly damage the leaf tissue if it enters directly into the stoma, and then through this it can to some extent damage the tree crown, right? So this will eventually lead to the death of the tree. On the other hand, if you have atmospheric pollutant in the form of acid, okay, acid deposition, this acid, okay, when it is in contact with the leaf, it can actually disturb the stoma. Okay? Stoma is actually one cell. If we have multiple cells, we call it as stomata. Okay, so because of the disturbance, you can increase transpiration, okay, which means water can move out from the leaf easier, right? So if you know that transpiration is, we are talking about the movement of water in the plant, right? From the roots to the leaves, right? So when we increase the transpiration, that means the water in the tree may be depleted, right? So you have water deficiency, and sometimes you can damage certain parts of the tree or the plants, which will cause nutrient deficiency, okay? Because of it can cause the inability of the plant to uptake nutrients, right? So you can have soil acidification, right? When you have acids, right? So these acids can go into the soil, and usually, right, heavy metals like to be released from the soil under acidic condition, right? So let's say you have this soil containing lead, containing copper, right? Or maybe cobalt. So this is immobilized heavy metals. It's not going to be available for the plants. But if you have acids, let's say you have acids contaminating the surrounding, this lead can actually leach out to become lead 2+, right? So when it leach out, then the plant will be taking up this lead into their roots. So when this happens, your plants will suffer from the toxic effects of the heavy metals, right? This is very commonly observed in countries like Sri Lanka and Bangladesh, whereby soil acidification happens, and then arsenic is being released to their soil, making it contaminated with these arsenics. Okay, so as I mentioned, stomatal opening is important because it regulates certain things like light, humidity, temperatures, and so on. Exposure of roots to toxicant is very, very crucial because it can cause chronic and acute effects, and it's easily being done. Okay, because when you have roots absorbing, you're actually absorbing water, and water is a very suitable media for the pollutant to be transported into the plant. Okay, just to show you the cross section of the leaf, right? So when you have a leaf, right, you have something called a stoma, right? Which is the opening, right? So this opening itself allows pollutant to move inside, and then there's an air space between different cells, right? So this air space is generally where the pollutant can move, right? It's very mobile, it can move around, and then it can affect all the different cells. So two different kind of injuries, acute injuries and chronic injuries, okay, can happen, right? So acute injury means that the absorption of this toxicant at an excessive rate. So when excessive rate of pollutant being absorbed, right, you have instantaneous effects. It can cause destruction of tissues and instant death of the plant. On the other hand, if you have chronic injury, usually this kind of injury, you'll see it in the form of the leaf becoming greener. Okay, it is a slow step. Okay, it's slow process. Usually, the chronic injury can be easily treated if you identify this faster, right? Just to show you that this is a photo of the plant, whereby you can see this is different in color. Okay, it becomes brownish in color. This means that the toxicant damage the chlorophyll. So the chlorophyll is an organelle that can cause green color, greenish in color. So if it's damaged, then it becomes yellowish. So this is one of the effects when you have pollutant entering into the leaf structure, right? So for human is more complicated in terms of the effects because human have more developed organs, right? So different organs will respond differently to the toxicant. And in terms of this exposure route, right, this one we have covered previously. We have dermal, ingestion, inhalation, whereby it goes into our different parts of our body. For example, dermal and inhalation, usually it goes to the lung, which will lead into alveoli, and then it goes to the our cardiovascular system. Whereas dermal contact, it also goes in the cardiovascular system. If it's ingestion, it goes into the liver, right? It prefers to go to the liver first for detoxification, and then after that, only it travels around the body, right? So in terms of the entry, okay, the toxic pollutant can enter into our body through all this, as I mentioned in the previous lecture, our dermal, respiratory, and also GI tract. And entry can be achieved through this filtration, passive diffusion, facilitated transport, and also active transport. So all these, they are the entry of the pollutant into our cell. Okay, and this active transport is the one that requires energy. Okay, this is the only one that will need energy because it is against the concentration barrier, which means that your pollutant is moving from the area of the low concentration to an area of higher concentration, right? So this is against the concentration barrier, which is why active transport needs energy, right? This is the only one. Okay? So once absorbed, of course, you know that the toxicant will be distributed, metabolized, and excreted. And when you have this distribution and metabolism, right, it can goes in your body, right? The toxicant can induce many adverse effects. So just to discuss with you, okay, this what are the kinds of toxic effects that we can actually observe, right? The first one will be the disruption of the cellular structure. Okay, so when you have, let's say, SO2, sulfur dioxide, going into the leaf structure, or when you have human being exposed to this sulfur dioxide, okay, it can actually affect the cell in the sense that it can destroy the cell structure. Right? It can react with certain chemicals in your cell, and then it will starts to cause death, okay, necrosis, right? The other one will be ozone. Okay? Ozone can induce peroxidation of your fats, livers, inside your liver, your body, right? So these are the example of effects, right? Toxic effects due to toxicant being present in your body. And this is classed under the destruction of cellular structure. Then we have direct chemical combination. For this one, we have the pollutant combined with the cell constituent. And this combination forms certain things, okay, certain toxicant or metabolites, okay, that is also toxic. And also the other one, it will be the combination of this pollutant with a certain cell that will cause it to be less useful. Okay, for example, let's look at one example would be this carbon monoxide, okay, binding with the hemoglobin. So when you have carbon monoxide binding with hemoglobin, it actually makes the cell of the red blood cell becomes less potent, okay, less useful, okay, for respiration, which means that your red blood cell cannot release oxygen and uptake oxygen anymore because it's deactivated due to the presence of carbon monoxide. The other one, effects that can turn your cell into something that is less useful would be the DNA structure being damaged by the epoxide, right? So we have a chemical called benzopyrene. So this benzopyrene is actually a chemical that can cause cancer, and it goes in our body, it is metabolized into metabolite, okay? And a metabolite called epoxide, right? So this epoxide is something that can react with your DNA and cause cancer. Just an example of this oxygen, right? Oxygen being attached to the hemoglobin. So from here you can see your oxidation state of iron is Fe3+ when you have oxygen being attached to it. But if you have carbon monoxide, it is Fe2+, right? You can see the difference, right? So if you have carbon monoxide being attached to it, it makes the oxygen not able to be bind to your hemoglobin. And for this case, if this happens, then your body will lose its ability to carry out respiration properly. Next effect will be the enzyme. So enzyme is abundant in our body. It is a large chemical structure. It consists of a lot of amino acids. And inhibition can happen, okay, when you have toxicant in many ways, right? First, it will be the enzyme inhibition due to inactivation of cofactors. So if you have an enzyme, right, for it to work, right, you need a cofactor plus the target substrate, okay? So this cofactor have to go into the enzyme with the target substrate for it to have catalysis, okay? So if you have a certain chemicals that can inhibit the cofactors, okay, you destroy the cofactors, you will see that the enzyme will not be able to function, right? Because the cofactor is important. First, to regulate the catalysis reaction. Second, sometimes to provide certain functional groups. Okay, if you remember last lecture, we talked about how the cofactor can donate a functional groups during the phase 2 metabolism. So if the cofactor is removed, right, so the phase 2 metabolism may not happen, right, because there's no cofactor to donate the functional groups to the toxicant. Right, so for this case, inactivation of cofactor, one example you can see is that the calcium cofactor can be removed by fluorine ion. So if you have a fluorine ion in your saliva, right, this fluorine ion can actually remove the calcium, right, and then you will make this so-called amylase. And this amylase is found in your saliva. it will make this amylase less effective, right? Because the cofactor has already been removed. So the cofactor cannot regulate the action of the amylase, and then after that, it will cause inactivation, right? The enzyme is not damaged. The enzyme is still there, just that it cannot function properly because there's no cofactor for it to function. The other one will be the inhibition by competition, okay? Competition with cofactor. For this case, you have the enzyme, right? You have multiple cofactor. For example, you have this one, and then maybe the other one, 2. Okay, cofactor number 2. This cofactor number 2 can bind with the enzyme, and then it is not as good as the original, the intended cofactor. Okay, then of course that will cause the enzyme to be inhibited. One example would be this cadmium and zinc. They are both chemically similar, but then of course zinc and cadmium, they differ in terms of the several things. For example, the size of the molecules, and in terms of the ability of this to react with other kind of functional groups. So because of this similarity, okay, you will see that they are actually causing different effects. Okay, they are actually inhibiting the enzyme. Then we have inhibition by binding with to active sites. So for this case, one example with is this catalyst, is this enzyme, alanine aminotransferase. Okay, this is an enzyme that catalyzes transamination. And then the other one is this aminolevulinic acid dehydratase, another enzyme. Both of these enzymes have this group, SH group. So if you remember this SH group, right, you know that this group is a very good group whereby heavy metals will like to attach to it. Right? So lead itself can attach to this SH group, right? Because this SH group is very, very stable when it forms the bond with the lead, right? So when this lead bonds with the SH group, it actually inhibits the enzyme activity. Right? This enzyme acts as a ligand, and then this lead attached to it. Okay. The other one is inhibition of enzyme activity by toxic metabolite. Okay, when you have fluorocitrate, this is also one example that I give in related to the resistance of the kangaroo. Right, so kangaroo in certain parts of Australia has resistance to fluorocitrate, but then most of the time, if you don't have the resistance to this fluorocitrate, you will die a violent death, right? Because this kind of fluorocitrate can actually inhibit our Krebs cycle, so it can cause effects to your metabolism. So another one would be the presence of a pollutant causing the release of certain substances. For example, pollen. So you absorb pollen in your body, it releases something called histamine, which can cause allergic reaction. So this allergic reaction is very dangerous to certain people because it can cause breathing problem, respiration problem. It can cause heartbeat to be increased. It can cause irregular blood pressure and so on, right? So histamine is something that is critical in allergic reaction. That's why sometimes those people who have allergic to certain chemicals, they eat this antihistamine so that they can be cured from all those effects, right? So another one would be this carbon tetrachloride, which is one of the chemicals that can cause the generation of radicals, right? Which can then damage our liver. Okay. Other secondary action, which is like chelation. Chelation is an effect whereby a metal can remove a certain metal from our body, right? And for instance, rabbits, if you look at an example of these rabbits, if they ingest carbon disulfide, this carbon disulfide can actually form a chemical in their body called this thiocarbonate and thiazolidone, which may quench all the zinc. Okay, they can actually, let's say you have an enzyme containing zinc. These kind of chemicals can actually take up the zinc, okay, make the zinc not available for the body, and then after that it can cause the loss of zinc in the body of the rabbits. Okay. So the other one is this kind of pollutants can also shift metals, right? The effects is like they can take one metal from one area and go to another area. So for instance, rats exposed to fluoride shows increase in zinc content in their serum. This is because the fluoride itself can transport the zinc from one side to the serum itself, right? Then another effect would be the free radical mediated reaction, whereby we see that a lot of this free radical being generated due to the ingestion of the toxicant, and then they can cause problem in terms of oxidation, and eventually it will cause oxidative stress to the human body, right? And finally, the last one, the effects that can be in our human body would be the endocrine disruption. So this endocrine is caused by the estrogen. Estrogen is a female hormone, right? This female hormone basically can mimic the action of this certain hormone in our body. Okay? This endocrine disruption is caused by estrogen mimic, right? For example, DDT, and then we have bisphenol A, right? They can enter in our body and then take up the receptors. For instance, this is an example, right? You have a hormone which can bind with the receptor. Then you have endocrine disruptor, the green color one, can also bind with our receptor, right? It can mimic the actions of the endocrine hormone, and then it causes effects. For example, this is the frogs, right? The frog have missing legs. It has more than two legs, and sometimes they can have different. Yeah, sorry for that. It means it's time for me to take medicine because my phone I set every day at 9:30 I have to take medicine, and it also asked me to stop already because I think the time is almost done. Just to finish up from this slide, right? So this slide shows that frogs they are affected by EDCs, endocrine disruptor, right? This is not the only case to the frogs, right? If you go to certain lakes, I don't know whether Indonesia you have this kind of problem or not, but in Malaysia we have this kind of problem a lot, right? If you go to certain lake in Malaysia, you see that the water is not so clean, right? And if you test the water, right, you can see that it's actually contaminated with endocrine disruptors. So if you take the fishes and then you analyze the gender of the fish, you'll see that some of the fishes, right, it has female reproduction parts. Okay, although it is a male, but then it develops female reproduction parts. This is some of the effects of the endocrine disruptor, right? This is also observed in countries like US. US, they have quite a lot of this problem, right? If you look at the YouTube, okay, you can go to YouTube, you can type endocrine disruptor. You'll see that there are a lot of videos. Okay, some of the videos show you how the frogs is affected, okay, how they have developed a female hormone. So I'll post the video in the website, okay, in my page, so that you can actually go through the videos to see that this is actually a very serious problem, right? It is something that is happening, right? I think I'll stop here. The transport, I'll cover it next week. Transport, we'll talk about how a chemical can actually change from one species to the other species, and how it can be transported from one side to the other side, and how different processes can actually affect the transport of the chemical. So we will look into it next week. So thank you so much for the time.
Thank you very much, Dr. Wenda, for very comprehensive lectures. So today, the topic is about the mode of the toxic actions. Many great examples, not only the toxic action in the plant, but also in the human. and also in the animals. Yeah. So to all students, if you have any questions, so please feel free.
Oh yeah, I saw in the chat.
Yeah, please.
Okay, so what is the main difference between mutagenic and carcinogenic? If not mistaken, both can cause cancer. Yeah, that's right. They are quite related to each other. In fact, we will cover about this topic in the coming lecture. And I think next week we'll cover it. The difference between carcinogenic, you have mutagenic, you have other different kind of effects, right? So generally, the difference between mutagenic and carcinogenic is that mutagenic, we talk about mutation, okay, mutation of our cell, our DNA, right? We can have mutation in the sense that it can be a problem to our offspring, okay, our children, because it mutates certain DNA, right? So because of this mutation, our body may suffer from cancer effects, may suffer from other effects, genetic effects, right? On the other hand, when we talk about carcinogenic, okay, carcinogenic is linked to cancer, right? It links to cancer only, which means that that particular pollutant can go into our body, it can cause cancer, right? So you can see the difference, right? Mutagenic is more on the ability of that particular toxicant to alter our genes and mutate our genes. Okay, it can cause mutation, right? Mutation is not necessarily lethal. Okay, mutation happens, but then it may not be a big problem, right? It can be just a small mutation, okay, change in DNA, not enough to cause cancer, right? On the other hand, when we talk about carcinogenic, we always talk about the cancer, right? These are the difference, which we will cover in the coming weeks. We will look at the difference and some of the examples of how we can actually distinguish between these two.
Thank you, Dr. Wenda.
Thank you.
Still any other questions, please? We still have around 5 minutes. And Dr. Wenda?
Yeah.
Yeah, regarding to the toxic actions of the pollutants in the human or animals, you mentioned there are three mechanisms, yeah, due to the passive diffusion, facilitated transport, and the active transport beside the energy. So what actually the difference, yeah, between three mechanisms that you mentioned?
Okay, so you're talking about this.
Is it really depends on the type of
this one, right?
toxicants, or yeah, this one. Maybe you can more describe about this.
We talk about the transport, right, of chemical agents, right, to the membrane, right? These are all these steps. They are not just for toxicant transport. They are also transports of nutrients to our cell, transport of hormones to our cell, and transport of any chemicals in and out from our cell. So if you look at our cell, it's actually a structure containing different kind of molecule. If you look at the cell, right, just draw it for you for the students to see. It's actually something like that. Right. You have a lipid arranging in such a way that it forms like a membrane. And then this is something that is very difficult to penetrate through. So we have certain pores around it, okay, to allow transfer of your solutes or molecules in and out from the cell. So sometimes we can have filtration, which means sometimes you have certain holes in this membrane, right? This is a bilayer, right? You have filtration. That means your small molecule can actually penetrate through it, right, easily. Then you have passive diffusion, right, through the space and pores, whereby sometimes things can actually dissolve in the lipid and then it moves up. Okay. And then we have facilitated transport, whereby you have specialized protein channels that can help you in terms of the bringing the pollutant in and out from the cell itself. So these are generally not the, I would say, pathway only for the toxicant. It is actually something that happens in our cell every day, because we need to transport nutrients, we need to transport chemicals, we need to transport all those energy molecules in our body, right? But then, of course, aside from those nutrients, toxicant pollutants sometimes can enter through this passage. So in terms of the mode of entry, sometimes the pollutant can have a specific structure that mimics a certain molecules in our body, right? Because of this mimicking, right? So they can enter through all these means, all these channels. Yeah.
So it really depends on the properties of the toxicants, maybe, yeah?
Yes, that's right. It depends on properties and sometimes
structures, yeah.
Yeah, sometimes let's say if you have something, a chemical that is hydrophobic. So hydrophobic is easier to enter into our cell compared to hydrophilic, right? So it depends on the properties.
Yeah. Thank you.
Okay, so I saw a question.
In the
research on benzo alpha pyrene for being a carcinogenic pollutant. But as far as I remember, PH contains a lot of types, including the benzo alpha pyrene itself. What makes this toxic? Okay, so this particular chemical is toxic because of several. Oops, sorry. Because it's iPhone sometimes it can I press and then okay, so this kind of chemicals, it is toxic because it can enters into our cell and it can cause several reactions to our DNA and certain part of our organelles, right? It is toxic mainly because it has the characteristic of being a toxic pollutant. For example, it is hydrophobic. Okay, it is relatively hydrophobic. It is able to alter our DNA. Yeah. So what makes PAH more toxic than other B? Okay, in terms of toxicity, it is generally just about the affinity. Okay, affinity of the toxicant to react with our so-called DNA. For example, if you talk about carcinogenicity and its effect to the DNA, right? Whether this pollutant is more toxic or less toxic, it depends on its ability to enter into the target area. For example, if you talk about DNA, right, the ability of this molecule to enter into our DNA and cause the effects. So it's all about that, right? So if you eat something, let's say you have PAH and BAP, right, to compare with these two, right? So the ability of this PAH to reach into our DNA as the absorb dose, right, may be lower compared to BAP, right? So this is one of the factors. The other factor will be the ability of this BAP to induce the effects in terms of the affinity, right? So if the affinity of this BAP reacts with the DNA is higher compared to the PAH, then of course the BAP will cause toxic effect. So in other words, what I'm trying to say is that there are two main factors in looking into the toxicity. One is in terms of whether these particular chemicals can reach the target organ at a high dosage, okay, in terms of the transport and distribution in our body. And the second factor will be the affinity of this toxicant to affect that particular target area, right? So this is my answer for this kind of questions. We talk about affinity and the ability of the toxicant to be reaching that particular area. Okay.
All right, Sipa, very great question, yeah, Dr. Wenda.
Yeah, this is a great question.
Yeah,
so
very nice.
Just to add in a bit more, there are several properties of the toxicant that will affect their ability to be distributed in our body. So if you compare the two different toxicants, right, one toxicant may be more hydrophobic, one it may be more hydrophilic. So this is one of the properties that can govern this the amount that is in the target organ, right? So yeah.
All right. So since it's already 8:42, I guess we come to the end of these lectures. But before we close, in the beginning of the lecture, Dr. Wenda just announced for the second assignment, that need to be prepared by all students. So if you have any questions or comments, as usual, maybe you can freely to contact Dr. Wenda, through WhatsApp or something. just in case you need more explanations on the preparation of your presentation. I guess it would be interesting, Dr. Wenda, and later on,
yes.
from this project, I can display on our YouTube department. Yeah, from the
we can actually showcase if it is very
and also in our department website. Yeah, hopefully it can be a kind of the great portfolio of the student how to say effort, yeah, on these lectures. All right, so if you still have any question, you can keep later in the next lecture next week. Before we continue the lecture, if you still have any question, you can deliver the question before the lecture. All right, Dr. Wenda, thank you very much again for your excellent lectures, and I deeply appreciate for your great preparations on these lectures, and very looking forward to see you again next week, and wish you a great day.
Thank you. You too.
Okay. Yeah, thank you very much. See you again.
See you.
Okay, thank you. Oke, saya sangat senang ya Anda bisa menyimak perkuliahan ini dengan baik. Kita beristirahat sejenak ya. Saya perlu minum obat sebelum melanjutkan kuliah ke perkuliahan berikutnya. Ini untuk mahasiswa S2 yang juga join di perkuliahan ini. Terima kasih banyak. Ini mudah-mudahan jadi tambahan knowledge gitu ya. Terutama kalau saya mengencourage, selalu saya share link perkuliahan yang berbahasa Inggris ini, karena kan jarang-jarang ya kita punya exposure, dan ini bisa mengetes readiness level Anda ya. Jadi kalau Anda nanti punya keinginan pengen kuliah di luar, seberapa persen kita bisa menyerap, dan itu satu fasilitasi. Jadi saya sebagai kaprodi dan juga sebagai dosen capek-capek juga dijabanin gitu ya untuk memfasilitasi Anda memperoleh exposure sebanyak mungkin dengan grade scientist dari luar, supaya knowledge Anda, learning experience Anda itu menjadi jauh lebih variabel. Ya, baik Siva dan kawan-kawan dan juga ada partisipan, saya kira saya bisa close dulu ya untuk Zoom ini, karena kita perlukan untuk record di pelaporan WCU, dan untuk perkuliahan analisis lingkungan saya akan kirimkan linknya berikut lagi. Boleh kita mulai dari jam 9?
Boleh, Ibu.
Ya, supaya saya minum obat dulu nih, supaya cepat sembuhnya. Baik, terima kasih banyak untuk atensinya. Silakan nanti dicek di link untuk akses assignment ya dari Dr. Wenda, dan terkait assignment pertama saya sangat bangga gitu ya. Dan tadi juga Dr. Wenda sangat mengencourage gitu ya, bahkan mahasiswa di USM katanya jarang juga gitu bisa completely fulfill assignment ini, mahasiswa Indonesia bisa melakukan itu. Jadi Anda keren lah ya. Ini satu challenge yang baik, dan mudah-mudahan nanti di yang kedua, di assignment kedua Anda juga bisa memenuhi dan mengerjakan tugasnya dengan baik. Untuk teaching material saya akan tarik dari link dan kemudian akan saya simpankan di spot, walaupun Anda secara personal bisa mengambil langsung ya. Terima kasih banyak. Selamat pagi, sampai berjumpa lagi nanti jam 9 di perkuliahan yang kedua. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih, Bu. Cepat sembuh.
Saya akan sampaikan di linknya ya. Baik.
Ibu.